Another type of special situation that we have with right triangles is 30, 60, 90 triangles. We talked about 45, 45, 90 triangles, and we know that the ratios that we use for 45, 45, 90 triangles are 1, 1 to 1 to root 2, or what we label our sides with is x, x, and x root 2. If we do a quick look at this equilateral triangle, we know that all of these angles are 60 degrees. And if I drop this altitude, then what that does is bisect that angle at the top, and that vertex angle, and this creates this 30, 60, 90 triangle. And so using what we know about that altitude, we know that if this length is 10, then what happens is it bisects that side. So this length is 5, and that's 10. And so then if I use Pythagorean theorem to find that other side, x squared plus 5 squared is equal to 10 squared. If we go in and simplify this, we get x squared is equal to, or not equal to, x squared plus 25 is equal to 100. Subtract 25 from both sides and you get that x squared is equal to 75. If we simplify that 75 and leave it in in a radical form, we have our pair of 5s that when we take the square root of both sides here, that pair of 5s comes outside, that leftover 3 stays inside. And so we can find out that that long leg is 5 root 3. And what's going to happen is every right triangle is always going to have this same ratio. So if I were to go through and divide everything by 5, if I were to divide by the short leg, what I find out is 5 over 5 is 1, 5 root 3 over 5 is root 3, and 10 over 5 is 2. And what we find out then is that the ratio of the sides for every 30, 60, 90 triangle is going to be in a ratio of 1 to root 3 to 2. Now, it's important that we understand where these pieces go. So the hypotenuse is always opposite of the 90-degree angle. The shorter leg is always opposite of the 30-degree angle, and the longer leg is opposite of the 60-degree angle. That goes with what we talked about earlier in the year about opposite sides, that short sides are across from small angles and long sides are across from large angles. So if this angle is 30 degrees and this angle is 60 degrees, then this is what is important to remember, is that we will always, because of those ratios that we discovered a second ago, we know that the short side will always be labeled x. We know that our hypotenuse will always be labeled 2x, and our long side will always be labeled x root 3. Now, I like to do them in that order just because the short side and the hypotenuse are the easiest sides to find, but you can do them in any order that you want. But it's important to remember 30 goes with x, 60 goes with x root 3, and 90 goes with 2x. So whatever order you label them in doesn't matter, just find the angles and then locate the sides. So we're going to do similar to what we did with 45, 45, 90 triangles. The first thing we're going to do is we're going to label our triangles with our sides, so with the labels that we have. So we need that if this angle is 60 degrees, this angle has to be 30 degrees. So our short side x is going to go across from the 30, so I'm going to put x is equal to 7, whatever's labeled on that side. And then 60 degrees is going to go across from the 60 degrees is going to be across from x root 3. So x root 3 is equal to a. You may have an x and a y there. I just changed them to a and c so they wouldn't get confusing with having too many x's since we're using x's in our ratios. And then c is equal to 2x. It doesn't matter whether you say c is equal to 2x or 2x is equal to c. That doesn't matter. I usually just do whatever I have, write it wherever I have the room to write it. So then the next thing, once you label it, you're going to solve. And what I mean by that is you're going to solve for x. Well, if you look, c is equal to 2x, there are too many variables. You can't solve for x. X root 3 is equal to a. Again, you have two variables. You can't solve for x. But x is equal to 7 is already solved. So we know that x is equal to 7. Well, if x is equal to 7, let's find a. Well, a is equal to x root 3. Well, we just said that x was 7. So we literally substitute. We erase that x and write a 7. So a has a length of 7 root 3. C is equal to 2 times x, and we just said x was 7, so it would be 2 times 7. So C is 14. So then the third step is to substitute. So we label, we solve, and we substitute. So let's practice with this one. So again, it's a 30, 60, 90 triangle. And so I'm going to put my x across from my 30 degrees. I'm going to put my x root 3 across from my 60 degrees. And I'm going to put my 2x across from my 90 degrees, or on my hypotenuse. So then we labeled it, now we solve it. So the only equation that I can solve is this one right here. So 20 is equal to 2x. Let's solve it for x. So we divide both sides by 2. So I get x is equal to 10. So if x is equal to 10 and b is equal to x, then b is equal to 10. And if a is equal to x root 3 and x is equal to 10, then a is equal to 10 root 3. We are literally replacing every x with a 10 because that's what we got, was that x is equal to 10. So if at any point you think that you understand, go ahead, work ahead of me, or put this on pause and try to work it by yourself and see if you understand it. Okay, so again, we're using our x root 3, and our 2x. These numbers are on your formula chart, so you can reference those. So x goes across from your short side, or from your small angles, so there's their 30 degrees. So I'm going to go over here and put a equals to x. Your x root 3 goes across from your 60 degrees, so equals to x root 3. And your 2x goes across from your 90 degrees, or on your hypotenuse. So look and decide which equation you can solve. You can't solve your hypotenuse. You can't solve your short side, but you can solve your long side. So we have 12 root 3 is equal to x times root 3. If I divide both sides by root 3, my root 3's cancel out, and my root 3's cancel out on that side. Remember, if you need to, you can draw your line in there. So you get that x is equal to 12. So if x is equal to 12, if a is equal to x, then a is equal to 12. And if c is equal to 2 times x, then c is equal to 2 times 12, which is 24.
1 minute to get to class.
Pardon the recordings.
1 minute.
So again, notice it's a 30, 60, 90 triangle. X goes on your short side, 2x goes on your hypotenuse, and x root 3 goes on your long side. Label them, solve them. So we set it up and we solve the one that we can solve. So I can solve that one. So I have 12 is equal to x root 3. So we divide by the square root of 3. Now we can't say that x is equal to 12 over root 3. You're not allowed to have roots in the denominator. So that's what we did last week, where we learned to rationalize the denominator. So we have multiply by whatever the square root is in the denominator. So I have 12 times the square root of 3. It has to stay like that because one is inside the radical and one's outside. Root 3 times root 3 is 3. And then if you notice, I've got these two, that 12 on the outside and that 3 in the denominator on the outside. Those will cancel down and leave you with that x is equal to 4 root 3. So we did all of that just to get to x. Now that we know what x is, then we can say, well, d is equal to 2 times x, or 2 times 4 root 3, which is 8 root 3. And c is equal to x, so c is equal to 4 root 3. I know this one looks a little bit weird because usually there's a square root of 3 on the 60 on the side across from the 60 on the long leg. But this one, it's technically built in. It's 12 root 3 root 3. And so, or it's 4 root 3 root 3. And so you, it's built in. So don't go by where the root 3's are or where the doubled side is. You have to go by where the angles are. So if we look at number 5, we have 4 root 2. Well, 4 root 2, that's the short leg, so that's going to be my x. Your c is your hypotenuse, so that's your 2x, and your a is your long leg, so that's your x root 3 side. Well, we've got it already. We've got our we've got our labels, then we've got our solving. It's already been done. So x is equal to 4 root 2. Well, then that means a is equal to x root 3, which means 4 root 2 times root 3, which is 4 root 6. Remember, when they're radicals, you can multiply them when they're either inside the radical or outside the radical. C is equal to 2 times x, or 2 times 4 root 2, which is equal to 8 root 2. And neither of those can be simplified, so that is it. So try these next ones on your own. If x is your short side, 2x is your hypotenuse, and x root 3 is your long side. Again, it doesn't matter what order you label those in as long as you put them on the correct sides. There's the equation I'm going to solve. So I'm going to divide by 2. I get that x is 18. Once I know that x is 18, if a is equal to x, then a is equal to 18. And if b is equal to x root 3, then b is equal to 18 root 3. Number 2. We've got our short side is x, our long leg is x root 3, and our hypotenuse is 2x. Label, then solve. We can only solve this one, and it is already solved for us, which is nice. So x is equal to root 3. If x is equal to root 3 and a is equal to x times the square root of 3, if x is 3, then a is 3 root 3. And then b is 2 times x. Well, x was 3, so it's 2 times 3, which is 6. Number 3, 48 is my short leg, b is my long leg, a is my hypotenuse. So I label it as such. I solve the equation that I can solve, so I know that x is equal to 48. If x is equal to 48 and a is 2 times x, then 2 times x would be 2 times 48, which is 96. And b is x root 3. Well, x was 48, so it would be 48 root 3. Those are your answers. And then for 4, we have a is our short side, b is our long leg, and 2 root 3 is our hypotenuse. So I have them labeled. Now we need to solve. 2 root 3 is equal to 2x. I need to solve for x. So I'm divide by 2 on both sides. So I get that x is equal to root 3. If x is root 3, if a is x, then a is root 3. And if b is x root 3, then b would be root 3 root 3. So b is 3. So those are your missing sides. So for 30, 60, 90 triangles, don't forget your magic numbers that go on your sides that you label them with is x goes across from the 30, x root 3 goes across from the 60, and 2x goes across from the 90. And then just to wrap special triangles all completely up, 45, 45, 90s. Remember that x goes across from the 45s, both of them, and x root 2 goes across from the 90. Let me write that a little bit better so you can see it. X root 2 goes across from the 90. You have to keep those numbers straight, but they will be on a formula chart that you